Alright, again on number 6 we have variable on both sides, and the right side has just the one term, so I'm going to leave that alone. Go to the left side where I've got multiple terms, get rid of the variable over there by subtracting it, which means I have to do it to both sides. And so that's going to cancel. The -5 or -5 comes down. Equal sign stays on the line. 7 minus 2 is 5n. And again, to get rid of the multiplication, we divide, this time by 5. That leaves me with 1n is equal to -1. And you can turn that back around with the variable on the left if you'd prefer. Alright, so I see I have distribution that needs to be done in number 7. That's always going to be done before anything else. So when I distribute here, 3 times m is 3m, 3 times 5 is 15, and then your 45 and your -7m come down on the right. And now I have the variable on both sides of the equation, but I have multiple terms on both sides, so I get to pick which one of these variable terms I'm going to eliminate. It does not matter which. I'm going to add the 7m to both sides. That's going to cancel over here. The 45 is going to come down. Equal sign stays on the line. 3 plus 7 is 10m, and your plus 15 comes down here. All right, now I'm back to a problem like I had in number 1 and number 6. Oh, I'm sorry, not number 6, just number 1, where I've got a two-step equation now. I want to isolate the variable. First step in that is to subtract 15 to get rid of that. So your 10m comes down. 45 minus 15 is 30. And now I'm down to a one-step equation where I want to undo the multiplication by dividing. And then 30 divided by 10 gives me a final answer of m is equal to 3. Okay, I have the variable on both sides here, but I also have other terms on both sides as well, so I get to choose what I want to do first. I'm going to subtract 4x from both sides to get rid of my variable on the right. The -16 comes down on the right. On the left, I've got 5 minus 4, which is 1x, and then your -4 comes down. And now I want to isolate my variable term. I do this by adding 4 to both sides. Your x comes down. -16 plus 4 is -12. The variable already has a coefficient of 1, so I am done at this point. And number 9, the difficulty level kind of shoots up a good bit here, so if you've kind of zoned out, then kind of wake up a little bit, sit up in your chair, and refocus on what we got going on up here. You see we've got 3 different locations in the equation where the variable shows up, and we also have distribution going on, so there's quite a bit here that we need to attend to. But as always, if I see parentheses, that tells me what I need to do first is go ahead and distribute. 4 times 3x is 12x, 4 times -5 is -20. The -4x just comes down here. I'm not doing anything with it. Equal sign stays. 2x plus 4 comes down. Okay, so in the first step, all I did was distribute the 4. Everything else just comes down as it was. All right, if I have like terms on one side of the equation or the other, okay, I'm referring to the left side versus the right side. If I have like terms included exclusively in one side, then I can combine those like terms. So I'm not referring to the fact that I've got a constant here and a constant here. Those are like terms, but one of them is on the left side of the equation, the other one is on the right side of the equation. So I can't just combine them and say -20 plus 4 is -16. Okay? The only way I can combine like terms is if I have a situation like this, where you've got 2 like terms both on the left side of the equation. And in this case, I do want to go ahead and combine those before I move forward. So 12 minus 4 leaves me with 8x. I still have my minus 20. And then on the right side, I didn't do anything. So I still have my 2x plus 4. Okay, now I'm back to the point where I have a variable and a constant on the left, a variable and a constant on the right, which we've seen several times already today. All right, so I get to pick which variable I want to eliminate. I'll go with the 2x. So subtract that from both sides. 8 minus 2 leaves me with 6x. The minus 20 comes down. The equal sign stays on the line, and the 4 comes down on the right side. And now I'm back to what I did in number 1, where I have just a two-step equation. Isolate the variable by adding 20 to both sides. Your 6x comes down. 4 plus 20 is 24. And then my last step is to get my coefficient of 1 on the variable by dividing both sides by 6. So x will be equal to 4. Number 10, very, very similar to number 9 in that I have distribution and more terms included here. So I've got to distribute first. That gives me 8b minus 24. Your plus 11 comes down, and your 8b minus 13 on the right side comes down. And again, if I have like terms exclusively on the left or on the right side, I can combine those. So I have a minus 24 and a plus 11 on the left side. These are like terms on the same side of the equation, which means I can combine them. So that gives me 8b minus 13 on the left, and then I bring down my 8b minus 13 on the right. And now at this point, you actually don't need to go any further, because now I have a true statement. I have the exact same thing on the left that I have on the right, which means no matter what I plug in for b, if I multiply it by 8 and subtract 13 on the left, and then I plug that same thing in and multiply it by 8 and subtract 13 on the right, I'm going to get the same thing no matter what that number is that I plugged in for b. So I have a true statement making this solution all real numbers. All right, now if you did not notice the fact that you have a true statement right here, then you can continue doing what we usually do, which is try to get the variable to one side or the other. But when you do that, it's going to cancel the variable on both sides and leave me with another true statement. In this case, the constant negative 13 is equal to negative 13. So it does not matter to me at what point you realize that you have a true statement, as long as you do realize it and you know that because I have a true statement, my solution is all real numbers. All right, now we're getting into distribution with fractions, which we've been working on the past few days here. So nothing changes as far as the process. The only thing that's changing here is that I'm distributing a fraction instead of distributing a whole number. All right, and with this first one, I'm going to go ahead and write out exactly what's going on here. We have a 1 over 7 being multiplied by 21g, which we can write over 1 like so. And then I have 1 over 7 being multiplied by 14, which can also be written as a fraction by putting it over 1. And then I have my 44 on the right that I haven't done anything to yet. All right, so I multiply fractions by simply multiplying across the top and multiplying across the bottom. So here I have 21g, and on the denominator I've got 7 times 1, which is 7. Here I've got 1 times 14, which is 14, over 7 times 1, which is 7. And again, my 44 is going to come down. Okay, now both of these fractions can be reduced. 21 divided by 7 is 3, and 14 divided by 7 is 2. And again, the 44 just comes down. All right, so I didn't do anything different than I've been doing. I'm just distributing a fraction and then reduce those fractions. Um, it's also possible, if you feel comfortable doing this, great. If you don't, then don't worry about it. But since I'm multiplying, you can cross reduce. Okay, both of these are divisible by 7, so that gives me a 1 here and a 3 here. And again, both of those are divisible by 7, so I get a 1 and a 2. And this just skips this step, right? So 1 times 3 is 3, 1 times 1 is 1, so that gets me straight to the 3g. 1 times 2 is 2 over 1 times 1 is 1. So if you cross reduce, you're just going to be skipping the step and not having to reduce the fractions. All right, now at this point, I'm back to what I had in number 1, just a two-step equation. So isolate the variable by subtracting 2 on both sides. 3g comes down, 44 minus 2 is 42. And then divide by 3 on both sides to undo that multiplication. So your final answer here, g is equal to 1, 12, 14. Right, once again, in number 12, I am distributing a fraction. Okay, so I have 1/5 times 5, which gives me 5/5, or 1x. Then 1/5 times negative 20, which gives me 20 over 5, which reduces to 4. Your equal sign stays on the line, and your 2x minus 3 comes down. All right, so now I'm back to something like I had in number 8, which we've seen several times. Okay, I've got variable on both sides, constant on both sides. I get to pick which one of the variables I want to eliminate. So I'm going to eliminate the x by subtracting it from both sides here. That goes away. The minus 4 comes down. Equal sign stays on the line. 2 minus 1 is 1x. And the minus 3 comes down. And now I have to isolate the variable term. So I'm going to undo the subtraction by adding 3 to both sides. That's going to cancel and leave me with x. And then negative 4 plus 3 is a negative 1. I already have a coefficient of 1 on my variable, so I'm done. And then you can always flip these back around to keep the variable on the left if you want to. All right, here I have multiple distributions that need to be done. I have a whole number being distributed on the left and a fraction being distributed on the right. 6 times k is 6k. 6 times 3 is 18. And then on the right, I have 1/4 times 16. This is 16 over 4, which reduces to 4. And then again, 1/4 times 16 would reduce to 4, and you've got your k there. Right now, I'm right back to where I've got variable and constant on both sides. So I just pick one of my variables to eliminate on one side or the other and get rid of that. Okay, your 4 is going to come down. Equal sign stays on the line. 6 minus 4 gives me 2k, and your plus 18 comes down. Now I'm back to a two-step equation where I want to isolate the variable, in this case by subtracting 18 from both sides. So your 2k comes down on the left. 4 minus 18 gives me a negative 14. And then my last step here is to undo that multiplication and get my coefficient of 1 on the variable by dividing both sides by 2.